Hello, I'm going to demonstrate the transformation geometry section translation. A translation is literally a copy and paste of an object around a page on a 2D plane. So the object stays identical, it doesn't rotate, it doesn't alter in shape. So there's no change in the dimensions or anything, or the rotation of the object. To start off, I think we need some learning outcomes. I'm going to do this through learning some terminology. So start here. The first term we want to learn is the object. Object, image, parallel, and equidistant. By the end of this lesson, we should understand why each of these terms are used in translations. So in transformation geometry, the original geometry is always called the object. So I'm going to label this here as the object. So there's one of our terms already ticked off. The object is always the original piece of geometry. The first step in translations is we look at what we're given. We're given this four-sided this irregular quadrilateral and the point A1. So first step is to join point A on the quadrilateral to point A1. This gives us a basis of where the movement is happening in our translation. So next thing we do is move all our, bring all our points A, B, or B, C, and D down parallel to A1. We can now see where the next term, our next term comes in parallel. So all lines must remain parallel in the translation. Next thing is to ensure that the image of the object will remain identical or congruent to the shape, to the object. We must make sure that each A, B, C, and D are their image points are all the exact same distance from the object points. So we want to get distance A1, and step it off each of the other points. Go B, label this point as B1. Without changing the compass distance, we go step off C, label this point as C1. Finally, off point D, vertex D, mark this point as D1. So just to recap there, we can see that A to A1, B to B1, C to C1 and D to D1 are all parallel. Now to tick off another point, another term that we have up here, equidistant. Equidistant means that they are all the same distance. This means that A to A1 is the same distance as D to D1, B to B1 and C to C1. So if we write this down, the length of A to A1 is equal to the length of B to B1 is equal to the length of C to C1 is equal to the length D to D1. So next thing we'll do is draw in our image. The image, as I've said a few times already, is the moved quadrilateral. So the object is the original and the image is your new quadrilateral. So label this as the image. So to recap, we were given the quadrilateral ABCD and point A1. We drew a line from A to A1 and then using our sliding set squares we brought a line parallel from A to A1, from B to B1, C to C1 and D to D1. We got the distance of A to A1 and we used the same distance and swung from B along the line found B1, C along the line found C1 and D along the line found D1. We joined up these 4 points and we were given our image. The image is the geometry once it has been moved through the translation or any transformation geometry. We now should know what an object is. It's the original piece of geometry. The image is our new piece of geometry. Parallel means all our lines are parallel and they are also equidistant. The distance from A to A1 is equal to B to B1, C to C1 and D to D1.